Okay, so just wanted to go through the review sheet for today. I'll lead you guys through it, and we'll see how everything goes. So first part is just a review of similar triangles. How do you identify if triangles are similar? There's three theorems. The first one is angle-angle. So all the two angles are congruent and two corresponding sets of angles are equal, then the triangles are similar. All the sides are proportional. So for this one, you're going to need to set up an extended ratio and show that these ratios are equal. When you're doing angle-angle and you're looking for triangles, make sure you actually find all the angles and compare. If you already have two that are equal, you don't need to get the third, but if you're not sure, find them all and compare. And the second one is, we're looking for two consecutive sides, so two sides that are next to each other, to see if they're proportional. So once again, you're going to do the proportion and show that their included angle is congruent. So the first one here, once again, we only have two sets of sides given, so we're not going to use side, and we don't have any angles, so we wouldn't use angle. If the lines are parallel to each other, we could use angle, because the side splitter theorem would give us the corresponding base angles. So really, we want to pay attention to the two triangles here. So this top triangle right there, and then the one down across the bottom. All right, so that's what we're looking for. Remember, this entire side here is 10, and this side here is 8. So their share angle Q, so there's our congruent angle, and then we can just compare. Is 10 to 3 equal to 8 over 2? So this side, big to small here, and we get 24 and 20, and we can show that those are actually not equal. So these are not similar, okay? And the reason is just the sides are not proportional. In number 2 here, we have these lovely triangles. And so we don't have any angles, so we're not going to use angle, right? And same thing with side, angle, side. We don't have any angles, so we're left with side, side, side. So we're going to do our extended proportion. And the trick here is that you get the corresponding sides. So just choose the smallest one over here, 12. Smallest one over here, 8. Choose the biggest one, 36, 24. And then the two that are left over, 30 and 20, and you're going to check to see if they're equal. All right, and what you should notice is that these all come out to be 3 over 2. This is called the scale factor. It could also be 2/3, and so we would say yes, these are similar, and the reason is they're side, side, side. We call it squiggly, right? That's similarity theorem. Okay, number 3, we have the same issue, right? We have the small triangle being formed here, and then the big triangle all the way around, okay? And once again, we have the side length here of 75, this one's 60, so they share angle H, there's our angle, and then is 50 over 75 equal to 40 over 60. In the case the answer is yes, they get us a scale factor of 2/3, and so we can say they are proportional, and then this is the side angle side similarity theorem, okay? And then last but not least, we have number 4 here. So in number 4, I can tell that these two angles are equal and that these aren't, but it doesn't mean that Z is not equal to J. So I got to make sure to check to see what these angles are. So let's start with this this triangle right here. So 76 plus 48 is 124. And then if we do 180 minus 124, we're left with 56. So this angle here is 56 degrees. It doesn't match these two. So 48, 76, you can see these aren't the same. We'll go ahead and find the sum of these two to get x. And you can see that this is 139. 180 minus 139 leaves us with 41. So this angle here is 41. And we would say no, because we only have one congruent angles. So we just say not all angles are equal, okay? All right. Number 5, two things. Don't find the value of number 5 here. Do not solve for x. It is going to be rough, okay, to do that. So we're going to skip this one. We're still going to answer, are they similar? And the answer here would be yes, because they both have these sets of angles that are equal. So it's the angle similarity theorem. That's the yes. Okay. Here's the number 6. This is that parallel line I was talking about. So you can see the two triangles are sharing, right? That angle. Once again, two triangles. So that guy there, and then the one that's all the way around it. All right. And then these sets of angles here are also corresponding. So we would once again do, and this is yes, the angle similarity theorem, and let's actually find x. Now, we can compare, right? We can't do top to bottom because we don't have top to bottom here. So we have to compare big triangle to small triangle. So in the small triangle here, this side x plus 1 corresponds to 2x plus 4. So I can make a ratio of these two sides, and they should be equal to the ratio over here, which is 6, and then this side, which is actually x plus 6. And now I can solve. So when I cross multiply, I'm going to get 6 times 2x plus 4 is equal to x plus 6 times x minus 1, I should say. All right. And now I'm going to distribute. So this is 12x plus 24. And this is x squared. We get 6x here and minus 1. So that's plus 5x. And then minus 6. Remember, we want to get this thing equal to 0. So we'll take away the 12x and take away the 24 and get x squared minus 7x minus 30. And then if we pull out the diamond here, what's going on? Should actually have that the other way then. So a times c is negative 30. And then b is the number in the middle, that's negative 7. So what numbers multiply to negative 30? You give us negative 7, so you can go through, right? 31, 15 and 2, 10 and 3, right? And so now we have x minus 10 times x plus 3, and then we solve. So x minus 10 is equal to 0, which means x is equal to 10, or x plus 3 is equal to 0, and x is equal to negative 3. What's going on? How'd it go? Oh, cool. All right. Sorry, zoning out here. So in the next question over here, right, are these similar? And so we can check we have an angle congruent in the middle, and that's all we have. So we want to check the proportions. So remember, it's 9 over 12 equal to 21 over 28. And so if you take out a 3 from here, right, we're going to get 3/4. Take out a 7, we'll get 3/4. So these are indeed equal. So the answer is yes, right? They're similar. And that's the side angle side similarity theorem. We also need to figure out what x is. So we're going to use our proportion here, right? We know that one of the sides, the small guys, are 9 and 12. And then these other two guys pair together. So these two are left to be. And if we did 9 to 12, we can do 18 over 4x minus 4, and now we can solve. So if we multiply through, okay, we're going to do 12 times 18 and get 216. And 9 times x minus 4, we're going to distribute, so this is 36x minus 36. So we'll add 36 to both sides. We're going to get 252 is equal to 36x. We'll divide out, and we get x is equal to 7. And so now we have the value of x here. Okay, and then in the last one, same deal. Are these? The answer is yes. We have the sides marked congruent. So this is the side similarity theorem. All right. Also, if all the sides are equal, right, that means these angles are all equal and they're actually 60 degrees. So you could use the angle similarity as well because it's equilateral triangles. But how do you find x? Once again, we're going to do the corresponding sides. You can also kind of do the fact that these sides are equal. So you could actually do 2x is equal to 4 and figure out that x is 2. Or do 10x minus 10 is equal to 10. You get 10x is equal to 20. You get x is equal to 2. Or you can do a proportion, right? 10x minus 10 over, let's say, 2x equals 10 over 4. And cross multiply. So it's 40x minus 40 is equal to 20x. And we can solve that way. So if we bring the x's over, we're going to get negative 40 is equal to negative 20x. And then we'll see that x is equal to 2. So any way you do it, you should get x is equal to 2. But there's 3 variations of it there for you. All right. On to the next page. So in the diagram below, which represents always a correct relationship between the segments. Listen, same thing. Altitude draw to the hypotenuse. Don't freak out. Draw your 3 right triangles that we talked about before. Label the sides, and then just check to see if those sides are actually in the same proportion. So we have hypotenuse of C, and then B, A. We have in this triangle on the right, we have a hypotenuse here of A. We have a long leg here of X, short leg of Z, and then in the small triangle over here, we have a hypotenuse of B, short leg of Y, and then a long leg of Z. So let's take a look. We got C and Z. So what triangle, or like C, Z's, and Y's? So I have a, which here can we compare that's going to do Z, right? Z and Y. And then we have also uses C. And this one we can't really get. The only C we have is this side right here, and that doesn't correspond to Z at all, so that's not going to work. Let's go to the second one, C and A and Y. So like C and A I can see right here. I have A's and X's, but I don't have any A's and Y's together, so that's out. And I have an XZ and Z and Y, so I have right here, you can see I have XZ and then Z and Y, so that would work. And if you look, we have YB and B and X, right? So YB and B and, no, that doesn't work either. So we're kind of stuck using these guys. You can see that's the only proportion that's actually going to work. C, A and Y, right? C and A. That means A and Y has to be in the same, and it's not. It should be A and X here instead of Y, right? And then we have C and Z, Z and Y. C and B. And I have B and Y, so actually these Z's should be B's here. And then down here, I have B and Y, right, and B and X, but it actually should be B and C. So you can kind of get the idea. The answer there should be 3. Let's actually use this now to do number 10. So, altitude drawn to the hypotenuse, okay, there. It means we're going to draw out our 3 triangles. So, there's one, a little smaller yet. All right, and then what do we got? So in the really big triangle, all I have here is an 8 and a 6. So I have those 2 sides. In the medium-sized triangle, I have a hypotenuse, right, of 8, and that's it. And in the small triangle, I have a short leg of X, and I have a hypotenuse of 6. And so when I'm looking at this, you actually would say, like, look, I got these 2 sides, but I don't have anything to match it with. Like, I would need these 2, and I don't have this one. But remember, if you have these 2, you can actually get this one by doing the Pythagorean theorem. So this question is a little tricky because it leaves you open to finding that other side. So when you combine like terms here, we're going to get 100 is equal to c squared, and then by the square root, we'll get that this is actually equal to 10, and now we can solve. So I have 6 and x for the first ratio, and then here I'm left with 10 and 6. So 36 is equal to 10x. We're going to divide out, and we get 3.6 is equal to x. And so that's the length of AD. So we do need this line, and then we're able to do it. Okay. And then this last one, we have the same exact situation here. Okay. We have the steel brace against here. So remember, when you cut this up, right, we can figure out this is 14. It cuts it into a short leg and a long leg. So now we can actually figure out our triangle. So we have this triangle going on here, right? We have the tall, medium, small guy, okay, and x. So in the really big triangle, I have 24 for the hypotenuse. That's all I got. And this guy, I have a long leg of 14, which makes x the short leg. And then we switch it up here. 10 is a short leg, x is a long leg. And then we can see our ratios. So 14 to x is x over 10. I get x squared is equal to 140. And then we're going to take the square root. So that's what we're looking for here. It says which equation. I'm guessing this is multiple choice, and we dropped it. So we'll just find x for this one. And let's go with simplest radical form, because we're crazy like that. So if I take 140 and we break it down, I get 14 and 10, 2, 7, 2, and 5. So x is equal to 2 2s, a 7, and a 5. Inside the square root, this is really 4. So we take the root of 4, right? And we end up with 2. We bring a 2 out. And then we have 35 left inside. And there's our radical. All right, I'll post another video of the other two solutions. School's about to end here, so it's going to a little crazy down my little actors. Signing off for now. Hope you guys enjoyed. Hope you learned something. We'll see you later.